Hi, welcome to another version of the electric BMW 320i project. No, this isn't green screen, this is actual wall of snow that's at the end of my driveway. If this gets any bigger, I won't be able to get the 320 out of the garage. But the best thing about all the snow is that I'm finally on skis, and it's really a good thing after my knee injury. So on this week's version of the show, I'm going to be showing how the LED headlamps and bulbs are useful and how much power they put out and how much light they use. And probably the biggest thing I'm going to be showing is, and the coolest thing, is I have a GSM module that I can do send text messaging to be able to control different parts of my car, which in this week I'll be showing how I do that to control the blower motor for the heater. So let's take a look. This is the last little bit on the heater box. I had to epoxy some plastic pieces on the ends here where the original water heat exchanger went through, and then go back and seal it up all real well with aluminum tape. Should make a nice seal and no air leaks. This is the last testing of the heater box for the BMW. I finished up all the taping to seal up all the holes, and what I did was, to control the speed of the motor, blower motor, I made this little microchip PIC circuit and a MOSFET, and driving that pulse width modulation to control the speed of the motor. Originally the motor was set up, had inside this blower box a set of resistors to control the speed, but I thought using the MOSFET I would save some energy. Probably don't need that big of a heat sink. This is only drawing about 3.5 amps, but I just thought I would start out like that and have the switch out of the vehicle mounted. So very interesting. When I set it up, the pulse width modulation, really to get the just about a little over 1.5 amps, it takes about 95% duty cycle, and there's a little bit of a funky waveform there, mostly because I'm putting this into an inductive load. Interesting that the motor would not work at 1000 Hertz pulse width modulation, but at 10 kilohertz it seems to work just fine. And then turning it up, now this is 95% duty cycle, and you see it pulls about 2.5 amps, and then all the way up, that's DC, essentially 100% duty cycle, and it draws about 3.5 amps. And that's got a pretty good glow coming out. So now I just have to package this up in a single box. Alright, today I'm going to take a look at comparing LED headlamps and LED lamps to their tungsten and halogen counterparts. This is what a LED headlamp looks like. Pretty much same for a 5 3/4 inch bulb, except it has this little set of electronics that drive the LEDs. Basically it's probably a voltage regulator. It takes the 12 volts down to the voltage that the LEDs need, and uses the same 2 or 3 prong plug that's on the car as compared to standard sealed headlamp. So I want to take a look at how that current is and brightness. So let's look at that. Here's the standard 5006 halogen bulb, and you see, turning on the low beam, of course has a tungsten filament or halogen. It draws a lot of current right away, but then drops, but drawing about 1.7 amps, and not very bright. And switch on the high beam. Now it's drawing 2.3 amps, and a little bit wider beam, but maybe twice as bright. Here's the low beam on the 24 watt LED lamp. See, it actually doesn't even draw 24 watts, it draws an amp and a half, and makes a really bright spot. It's supposed to be 2400 lumens. I really don't have a way to measure that here. I could bring an instrument from work, but you can see that's way brighter than even the high beam is on the standard halogen lamp. And the high beam, when switched on, is even brighter. I think probably what they do is they just switch from one to the other because it's only drawing an amp and a half. It just looks like it's maybe aimed a little bit higher, but still very bright. Here's the LED high beam lamp, and it just has two connections on it, and it's pretty much the same as the low beam. Switch it on, draws about, actually a little bit less, 1.4 amps, and the beam's a lot more dispersed, a lot higher patterned, so obviously for being a high beam, but still much brighter than the high beam on the halogen lamps. Now I'll take a look at the difference between the small bulbs used for turn signals and brake lights. It's a regular old 1157 bulb. You see it draws 400 milliamps, and it's not particularly bright. Here's an 1156 bulb LED lamp. See, it only draws 120 milliamps, but it is very bright. So the LED lamps really help out a lot for the turn signals and brake lights and backup lights. Here are the results of the LED testing. Shows the bulbs are really efficient. They put out a lot of light. The headlamps can be found on eBay. They're just it's really weird. They just show them as Chevy or Pontiac, but that's because they're a 5 3/4 inch bulb, which has only been really used on old cars. But the specs are all about the same, and they all seem to work really well. Certainly brighter than anything else. I'm going to talk about something pretty cool. When I first got my Leaf, it had a iPhone app that allowed you to check out the state of charge, or be able to even start the charging, or you could turn on the air conditioning or the heating. I'll show you some looks at that app here. And I thought, well, that would be a really cool thing for my 320 to do. And I had to have some experience doing machine-to-machine control with these GMS modules that can send text messaging or SMS. And I knew about that they were possible, and I found that there's several of them that work right with the Arduino Uno, like this. This is actually the Arduino GMS module. It is one of the more pricey ones, but it does have a great advantage. I'll show you the website. They have full documentation on it, but the biggest advantage, and I'll show you that here, is that there's a GMS library, and that library is already built into the IDE. So all of these GMS modules, and the chip that's on here, that's the modem, they all use AT commands, and that goes way back to the days of the Hayes modem, and the same kind of AT commands. Now I'll show you, here's an alternative GMS module, which is a little less money than the Arduino version, but it only works on AT commands, and so you have to build all those structures up inside your program. Now that's not, if you're not doing a lot of things, just sending text back and forth, maybe it's not that big of a deal, but having them built right into the functions into the IDE works really well. And so the only thing that you have to do with this module is you have to get a SIM card for it. Now the Arduino one, it actually comes with a SIM card, but unfortunately that only works for European phones, or it will work for another. If you got a second one of these, you could talk between those two if you activated the card, but it's not very useful. I wanted to have one that I could use with my iPhone and be able to text message to it. So what I looked into is getting a GMS that's local, and T-Mobile is actually on GMS network, and so what I did was I bought a SIM card and a plan. And here I'll show you the website for the SIM card, which you can buy right online, very inexpensive. And then what T-Mobile has is a really good pay-as-you-go plan. It's only $3 a month, and that gives you 30 text messages. And that's great. And actually, if you go over that, it's only 10 cents a message. But what I found using my iPhone was that app for the Leaf, I've never accessed it every day. And I don't think I would do that with the 320, but again, it's not a lot of money if I do. So the process is, once you have the purchase and you actually have the physical SIM card, then you go through an activation process, which is basically entering the information from the SIM card and then also the information from the GMS module. And there's a number on here, and I'll show you a picture of that. That's just an identification number for that particular modem. And once you put all that information in, and this is what the activation site looks like for T-Mobile, then they will assign a local phone number to you and that SIM card, and from that point on, then you can text message it. And what I found with this module was once I got that activation done and I plugged it in and fired up the first sketch, it worked right away. I was able to send and receive text messages with my iPhone. So I think that was a really good choice to do. But again, you could probably set that up and use the alternative ones, which are less money, but you have to write your own programs. So what I'm going to do first with this is show you how I used it to the text messaging to control the speed of the blower motor in my heater. And eventually I'm going to be using it to do all kinds of things, and maybe even at some point get the state of charge out of the car. But let's take a look and see how that goes with the blower motor. Well, here's a demonstration of the text messaging and program I wrote that will do the work of turning the blower motor on the heater unit. So here I have my phone set up, and of course the name, that's what I put in my phone as the number. And so it's just regular old text messaging, just send it. And in a few seconds it should show up, and there it is. So that word heater turns on the heating unit, and then another text. A word just will then set the speed. It's just very simple strings. It's easy to parse them up and figure out what it's supposed to be doing. So that's what I'll be showing on the blower for the heater. Here's the setup with the heater module for the BMW. You saw this before when I was testing out the pulse width modulation, driving it with the switch. Well, here's the little PIC board, which I've cleaned up, and I mounted the MOSFET right onto it. And instead of having the switch connected to it, I have the Arduino GMS module. And so just my cell phone and then a power supply. So I'll set this up so I can enter the text, and you can see that it works to turn the blower motor on. So here I'm going to enter the text heat 1 and send. And take a few seconds. There it goes to start it up, blowing a little bit. See, it's drawing an 1.5 amps. Now I put in heat 2, should be the medium speed. There it goes, spins right up to medium speed, about 2.5 amps. And then heat 3, it's full speed, but I don't think this power supply can do that full current. There it is. And then I send heat 0. And it shuts down. So it shows how well this system would work. Of course, you know, part of all this would be obviously you'd want to have some kind of password protection so that in case somebody found this telephone number and they started hacking into it and trying to set things, you don't want your car doing things while you're not there. So again, very easy because the text comes in as, you know, a string that can be manipulated any way you want, and you could have any number of characters as a password. The only downside of it is that every text that's sent in is counted as one of your texts, so you know somebody could run up your 30 texts pretty quick. But I'm not really too worried about that. Not too many people are going to know this phone number, and that you don't really see that on your cell phone very often, that people are trying to hack into it with text messaging. But anyways, but it does seem to work really well, and I think this is just the beginning of some really neat stuff to do with it in the car. So that GSM Arduino is a pretty cool little thing. Be able to control the car via text messaging. I think that's going to be really something that's going to have a lot of different applications in the car. Like I said, I might be able to even control or get the state of charge and maybe start the charging. I'll have to see. The only issue with that is that there'll have to be a 12-volt circuit live all the time. Now, that I was already considering putting a small lead acid battery in just for that, because I also plan to have electric remote door locks. Now, those two remote wireless things only draw a few milliamps, but again, like I showed with my Leaf, if you let the car sit for a month or two, you might even draw down the 12-volt battery. So it's just something to consider, but I think when you're doing it as a daily driver, not an issue. And the only thing that I'm a little bit concerned about is with the heater. The only way I can turn the heat on is I have to set or close the main contactors. And I guess, you know, I want to make sure that there's a lot of fail-safes around that if I'm doing that remotely and I'm not in the car. But we'll be doing that later, and we'll see how it works out. Thanks for watching, and catch you again.